Welcome back to Kamal Kunj Home Academy, Encounter with Mathematics. In this session, we will discuss about the characteristics of rational numbers. Characteristics of rational numbers. Number one. Now we have already discussed about rational numbers in session 1. So here first characteristic is any rational number can be expressed as a fraction P upon Q, where P and Q are integers. And Q is not equal to 0. So, rational numbers can be expressed in the form of fraction P upon Q, where P and Q belongs to integers. P and Q are integers and Q is not equal to 0. Second characteristic, in the form of decimal fraction, in the form of decimal, rational numbers are either terminating or non-terminating repeating. Repeating decimal. So, when rational numbers, when expressed in decimal form, they are either terminating decimal or non-terminating repeating decimal, or also called recurring decimal. For example, terminating 2/3 is equal to 0.6, 0.6. This is non-terminating but repeating. This can be written as 0.6. This is non-terminating but repeating. This is called recurring rational numbers. And terminating 5, 0.8. This is terminating. Now if x is any rational number, x is any rational number whose simplest form is P upon Q, where P and Q belongs to integers and Q is not equal to 0. If x is any rational number whose simplest form is P upon Q, P upon Q is the simplest form, that is no common factors except 1, where P and Q are integers and Q is not equal to 0, then x is terminating rational number if the denominator, that is Q, is equal to 2 to the power n multiplied by 5 to the power n, where m and n are positive integers. It is if prime factors of Q, that is denominators, are 2 and 5 only, then that rational number will be terminating. Decimal form, in decimal form, that will be terminating, and it will be non-repeating, but it will be non-terminating, but repeating. Non-terminating repeating. If Q is not equal to 2 to the power n and 5 to the power n. Now if 2 and 5 are the only prime factors of Q, then it will be either terminating or it will be non-repeating if it is not equal to, if 2 and 5 are prime factors are not there in the prime factorization of Q, then it will be non-terminating repeating. Next is all the numbers, the natural numbers, whole numbers and integers are subset of rational numbers. Means rational numbers include all whole numbers and all integers. All natural numbers all whole numbers and all integers are subset of rational numbers. Subsets of rational numbers. Means rational numbers include all natural numbers, whole numbers and integers. Closure property. If A and B are rational numbers, Then A plus B will be also rational number. A minus B will be also rational number, and multiplication of A and B will be also rational number. If A and B are into rational numbers, then their sum will be also rational numbers. Their subtraction will be also rational numbers, and multiplication will be also rational numbers. It means they are closed. Rational numbers are closed for addition, subtraction and multiplication. But it is now closed for division. Reason is rational numbers are not closed for division because division by 0 is not defined. Except 0, all other numbers are closed. Except 0, all other rational numbers are closed. Next characteristic is commutative law. Commutative law. If A and B are two rational numbers, A and B are two rational numbers, then commutative law for addition, A plus B is equal to B plus A. Rational numbers obeys commutative law for addition. and commutative law for multiplication for A multiplied by B is equal to B multiplied by A, which means always the commutative law for multiplication also. It is not true for subtraction or division. Commutative law is not valid for subtraction and division. Associative law. Associative law. If A, B and C are rational numbers, then for addition A plus B plus C is equal to A plus B plus C. For multiplication, A into B into multiplied by C is equal to A multiplied by B multiplied by C. It is not true for subtraction. A minus B minus C will not be equal to A minus B minus C. Or it is also not true for division. Next, identity element. Identity element. For addition, if A belongs to Q, A is any rational numbers, then A plus 0 equal to A. So here 0 is called identity element for addition. 0 is called identity element for addition. And for identity element for multiplication is A multiplied by 1 is equal to A. Here 1 is called identity element for multiplication. For multiplication. Next is additive inverse and multiplicative inverse. Additive inverse. Additive inverse. If A is any rational number, A belongs to Q, that is rational number, then A plus minus A is equal to 0. It means A and minus A both are additive inverse of each other. Minus A is the additive inverse of A and A is the additive inverse of minus A. Both are additive inverse of each other. And multiplicative inverse. Multiplicative inverse. A multiplied by 1 upon A equal to 1. So A and 1 upon A both are multiplicative inverse of each other. 1 upon A is the multiplicative inverse of A and A is the multiplicative inverse of 1 upon A. Now we will stop here and continue further in the next session. Till then, goodbye and thanks for watching.